Good morning, student. Let us see the next part of this chapter, that is a solution of triangle. In that, first we will see sine rule. In triangle ABC, A upon sine A is equal to B upon sine B is equal to C upon sine C. This is called as sine rule. This is equal to 2r, where r is the radius of the circumference of circle. This is equal to 2r, where r is circumradius of triangle ABC. Or we can say that other forms of sine rule. 1. A upon sine A is equal to B upon sine B is equal to C upon sine C is equal to K. This is constant. K is constant here. From this we can write A is equal to K into sine A. B is equal to, we can write K into sine B. And C is equal to, we can write K into sine C. Second form of sine rule is sine A upon A is equal to sine B upon B is equal to sine C upon C is equal to K. Say constant K is. From this we can write sine A is equal to AK. Sine B is equal to BK. And sine C is equal to, we can write CK. Isn't it? In this way also we can express sine rule. Now another form, third form of sine rule is A is to B is to C can be written as sine A is to sine B is to sine C. This is also one of the form of sine rule. By using this sine rule, we can solve number of problems in exercise 3.2. Isn't it? Next topic of this chapter is second one is cosine rule. Let us see cosine rule. In triangle ABC, one, A square is equal to B square plus C square minus twice BC into cos A. This is 1. Second, B square is equal to C square plus A square minus twice AC or CA into cos B. And third one is C square is equal to A square plus B square minus twice AB into cos C. This is called as cosine rule. Other form, forms of cosine rule. 1. Cos A is equal to, from this equation we can get b square plus c square minus a square upon twice bc. Second, cos b is equal to, from this we can get c square plus a square minus b square upon twice ac. And third one, cos c is equal to a square plus b square minus c square upon twice ab. In this way we can express cosine rule, isn't it? We will use this cosine rule for solving the problems. Keep in mind, learn this cosine rule. Very simple. Here a square is there, here cos a is there. B square c square, here bc. Here b square is there, here cos b. And c square a square, therefore ac. C square is there, therefore cos c. A square b square, here twice ab. By this order you can learn this. Very simple. b square c square minus a square twice bc. C square a square minus b square twice ac. A square b square minus c square twice ab cos c. In this way you can learn cosine rule, isn't it? Now next, third one is projection rule. Projection rule. In triangle ABC, first A is equal to B cos C plus C cos B. Second, B is equal to C cos A plus A cos C. And third one, C is equal to A cos B plus B cos A. This is called as projection rule. We will use this projection rule for solving the problems in exercise 3.2. Let us see exercise 3.2 and we will see the proofs later on, isn't it? Exercise 3.2, question number 1. In exercise 3.2, question number 1 and 2 we have already solved, which is based on the Cartesian and polar coordinate, isn't it? Now we will solve the remaining sums in exercise 3.2. So we will start from question number 3. Question is like this. In triangle ABC, if angle A is equal to 45 degree, angle B is equal to 60 degree, then find the ratio of its sides. Solution: to find ratio of sides of triangle ABC, that is to find A is to B is to C is equal to question mark. That we are going to find in this sum. given angle A is equal to 45 degree, angle B is equal to 60 degree, we know angle A plus angle B plus angle C is equal to 180 degree. Therefore 45 degree plus 60 degree plus angle C is equal to 180 degree. Therefore angle C is equal to 180 degree minus 105 degree. Therefore angle C is equal to 75 degree. Isn't it? Now by using sine rule, we can write A upon sine A is equal to B upon sine B is equal to C upon sine C. Isn't it? Now that is here A upon sine 45 degree is equal to B upon sine 60 degree is equal to C upon sine 75 degree. We know the values of 45 degree, 60 degree, but we don't know. So first we will find sine 75 degree. Now sine 75 degree can be written as sine 45 degree plus 30 degree. We know sine A plus B is equal to sine A into cos B plus cos A into sine B, isn't it? Therefore sine 75 degree is equal to sine 45 degree into cos 30 degree plus cos 45 degree into sine 30 degree. We know the values 1 upon root 2 into root 3 by 2 plus 1 upon root 2 into 1 by 2, that is equal to root 3 plus 1 upon 2 root 2 sine 75 degree is equal to. Isn't it? A upon sine A, sine 45 degree, B upon sine 60 degree is equal to C upon sine 75 degree. Now we put the values. Therefore A upon sine 45 means 1 upon root 2 is equal to B upon sine 60 degree means root 3 by 2 is equal to C upon sine 75 degree means root 3 plus 1 upon 2 root 2. Isn't it? We know that A is to B is to C is equal to sine A is to sine B is to sine C. Therefore A is to B is to C is equal to sin 45 degree is to sin 60 degree is to sin 75 degree. A is to B is to C is equal to 1 upon root 2 is to root 3 by 2 is to 3 root 3 plus 1 upon 2 root 2. This can be written as A is to B is to C is equal to 2 upon 2 root 2 is to root 3 into root 2 upon 2 root 2 is to root 3 plus 1 upon 2 root 2. Therefore, A is to B is to C is equal to 2 is to root 6 is to root 3 plus 1 is the required ratio of sides of triangle ABC. In this way we can solve this sum. Question number 1. Now let us see question number 3. Question number 4. We are going to see question number 4. In triangle ABC, prove that sin B minus C upon 2 is equal to B minus C upon A into cos A by 2. Proof. RHS is equal to B minus C upon A into cos A by 2. By using sine rule, we have A is equal to K into sine A, B is equal to K into sine B, C is equal to K into sine C. Therefore, K into sine B minus K into sine C upon K into sine A into cos A by 2 as it is. Taking K as common, in bracket we have sine B minus sine C upon K into sine A into cos A by 2 as it is. K get cancelled. We have sine B minus sine C upon sine A into cos A by 2. This is our RHS. We are going. We know that sin B minus sin C is equal to 2 cos B plus C upon 2 into sin B minus C upon 2. Also, sin theta is equal to 2 sin theta by 2 into cos theta by 2. Therefore sin A is equal to 2 sin A by 2 into cos A by 2. Therefore RHS become RHS is equal to 2 cos B plus C upon 2 into sin B minus C upon 2 whole divided by 2 sin A upon 2 into cos A upon 2 into cos A upon 2. Cos A upon 2, cos A upon 2 get cancelled. We have 2 cos B plus C means pi minus A upon 2 into sin B minus C upon 2 upon 2 sin A upon 2. Since A plus B plus C is equal to pi, implies that B plus C is equal to pi minus A. Which is equal to 2 cos pi by 2 minus A by 2 into sin B minus C upon 2 upon 2 sin A upon 2. This 2 get cancelled. Cos pi by 2 minus theta is equal to sin theta, sin A by 2 into sin B minus C upon 2 upon sin A by 2. Since cos pi by 2 minus theta is equal to sin theta. Therefore sin A by 2 get cancelled. Sin B minus C upon 2. Thus RHS is equal to LHS. Hence proved. In this way we can solve question number 4, isn't it? Remaining questions we will see in coming video.